So maybe you've already watched the video where we worked through adding and subtracting. We're now going to, in this video, we're going to work through multiplication and division. But just as a reminder, in case you didn't watch the first video, there are some established meanings that I'm assuming here. We're assuming that students already understand what addition, subtraction, multiplication, and division really mean. And I'll remind you of those meanings as we go through this video. I'm also assuming that they understand this is sea of zeros idea, that if you have matching positive and negative pairs, that they will combine to make 0, like positive 3 and negative 3 combine to make 0. And I also am assuming that students aren't just counting chips. They're not just saying, you have 47 chips on the board, but they're actually thinking about the value of those chips. Positives and negatives make 0, for example. So those are the established meanings that we would have to have before we move into the operations. So we're now going to focus on multiplication. And you know, the big buzzword in our workshops has been copies of. But it is really important, not only for this topic, but the idea of copies of extends through college algebra, pre-calculus, trigonometry, calculus. We've seen, it just goes and goes and goes and goes. And so it's a really important idea to begin as early as possible. So when I see 4 times 2, what I think about is 4 copies of 2. So notice on the whiteboard right now, or if you are working on your desktop, I start with nothing. And what I'm going to do is, based on my problem setting, I'm going to do what it says. So positive 4. So for me, positive 4 means I'm going to introduce, or I'm going to put on the board 4 copies of 2. Everything's positive. So there's a copy of 2 positive. There's a copy of 2 positives. There's a copy of 2 positives. There's a copy of 2 positives. So I've got 1, 2, 3, 4 copies of 2, 2, 4, 6, 8 total chips. So the idea here is, as we move on, we're going to start with nothing and then interpret the problem. Positive 4 means I'm going to introduce to my nothing 4 copies of. Now, 4 copies of what? In this case, I have 4 copies of negative 2's. So there's a negative 2, there's a negative 2, there's a negative 2, there's a negative 2. And so 4 copies of negative 2, a bunch of copies of negatives gives me negatives. So 4 copies of negative 2 gives me negative 8. So again, like with the other operations, what we're shooting for is through meaning. Students are really thinking about what multiplication means. They will eventually, through repeated reasoning, come to the point where they'll say, oh, so a positive times a negative always gives a negative. Because if you have 4 copies of negatives, if you're putting on the table a whole bunch of negatives, you're going to have negatives. So is that always the case? That a positive times a negative is a negative? Yes. And when students can articulate that, you make the poster, you put it on the wall, and you name the rule after them. Now, when we get to a negative 4 times 2, things get a little bit more dicey because the negative sign out front has to be interpreted in some way. And as you've seen in the workshops, there's a couple of ways you can interpret. I'll try to remind you of them here. But I just want to point out, looking back now at addition, subtraction, multiplication, division, this is the one area where you kind of have to make a rule for the context. Now, I'm not saying you have to make it, but working with your students, a rule has to emerge about how we're going to interpret that. But that's the only place. Everything else just kind of flows naturally. So we have to interpret it. Here's how I interpret it. Earlier I said you start with nothing and then you do what it says. Positives mean put on. So what's the opposite of put on? Take off. So I'm going to take off 4 copies of 2. So I'm interpreting this negative sign as an opposite symbol. I'm going to do the opposite of what I did over here. Instead of putting on the table some copies of, I'm going to take off the table some copies of. But I still have to start with nothing. So I'm going to introduce the old sea of zeros once again. Now, again, students may not know how many to introduce. We probably can figure it out because we know 4 times 2 is 8. But let's just kind of work through this. So I'm going to introduce my sea of zeros. So I start with nothing. and then I do what it says, the opposite of what I did over here. Take off 4 copies of 2. 2 what's? Those are positive 2's. So I'm going to take off 4 copies of positive 2's. Let me do it this way. I'll just circle them. I'm going to take off that copy of positive 2. I'm going to take off that copy of positive 2. I'm going to take off that positive 2. I'm going to take off that positive 2. Now when I take off all of those positive 2's, 4 copies of positive 2's, what am I left with? I'm just left with the negatives. When you take off the positives, you're going to be left with the negatives, thus the negative 8. Now another way people have done this, which I think is wonderful, especially with the chips, is they'll kind of ignore the negative sign for a moment. They'll say 4 copies of 2. There's a copy of 2, there's a copy of 2, there's a copy of 2, there's a copy of 2. The negative sign, again, could be interpreted as do the opposite. Now with the chips, what we did is we flipped over the chips. So imagine we flipped over the chips, made that one negative, made that one negative, and negative, negative, negative. When you flip over all the chips and make them all negative, you also can see the negative 8 emerge. So likewise over here, negative 4 times negative 2. A negative times a negative is a positive. Why? Because we have to interpret that lead-off negative sign in some way. And the way we interpret it is either opposite, flip the chips over, or take off the table. So I like the take off the table way of thinking about it. So this tells me, start with nothing still, start with an empty slate, but not literally an empty slate. Let's start with a sea of zeros. In terms of value, again, this is why it's so important that students come into addition, subtraction, multiplication, and division with those established meanings, one of which is you can represent quantities in multiple ways. This still represents 0 in terms of value. Now, what I'm going to do is take off the table. I'm going to interpret that lead-off negative sign as take off the table. 4 copies of negative 2. So if I take off a negative 2 and take off a negative 2 and take off a negative 2 and take off a negative 2, what am I left with? Well, if you take off all the negatives, you're left with the positives. So can you imagine students going through multiple experiences maybe, but eventually they come to realize that taking off the negatives is going to leave the positives, and they say that means a negative times a negative is always positive. Yes. Put it on the board or on the wall as soon as it gets established as a rule. Now, multiplication. We go to division. Division is the inverse operation. So instead of knowing how many copies of, we have to determine how many copies of. So the way we interpret this question is, think of this as like our question over here. This says, how many copies of 2 does it take to make 8? So you start playing with that and see, well, there's a copy of 2. Do I have 8 yet? No. There's a copy of 2. Do I have 8 yet? Nope, not yet. Keep going. How about now? No. Keep going. How about now? 2, 4, 6, 8. Yes, there it is. So how many copies of 2 did it take to make 8? 1, 2, 3, 4. It took 4 copies of 2 to make 8. Now, knowing that we're going to get into integer land here in a moment, let's also make a connection here back to multiplication. 4 copies of 2 make 8. Now, would I have to put on copies of 2 to eventually get 8, or would I have to take off copies of 2 to get 8? Well, if you rewind this video, you'll see that what I did is I put on a copy of 2. I put on a copy of 2. I put on. So since I'm putting on copies of 2, it's positive. Put on 4 copies of 2 to get 8. So I'm really leaning heavily on how I understood multiplication back here to make sense of my division here. I hope you can see the connections. Just that I have to work it backwards. I have to decide, am I going to put on or take off? How many copies of 2 will I put on or take off to get 8? I'm going to put on 4 copies of 2 to get 8. Now come over here and see if you can see this work. So the question is, how many copies of negative 2 is it going to take to make negative 8? And secondly, will I put them on or take them off? So let's imagine this. Would I put on negative 2's? to eventually arrive at negative 8? Or would I take off the negatives to arrive at the negatives? Well, just put them on. I'm going to put on negative 2's until I get to negative 8. Now, putting on copies of is a positive. Again, going back to multiplication, putting on is a positive. So I know my answer is positive. Furthermore, I can kind of leverage what we learned in multiplication in this way. Since multiplication and division are inverse operations, shouldn't the rules follow? A negative times a negative made a positive. A negative divided by a negative should also make a positive. But even more than that, it's this idea of start with nothing and either put on or take off. I'm going to put on negative 2's until I get to negative 8. So put on a negative 2. Am I there yet? Nope, not yet. Put on a negative 2. Am I there yet? Nope, not yet. So I'm putting on copies of negative 2 until I get to negative 8. Keep going until you get to negative 8. How many copies? The question is, how many copies of negative 2 did it take to make negative 8? 1, 2, 3, 4. It took 4 of them. And I say positive 4 because I put them on the table. I did not take them off the table. Now, it gets a little more challenging here when you have something like this. Now, the question still is, how many copies of negative 2 is it going to take to make 8? Now, if you start making copies of negative 2's, you can make copies of negative 2 until the battery dies on this camera. And you're still not going to ever get positive 8 out of it. And so we have to rethink that a little bit. And the way we're going to rethink that is, am I going to put on negative 2's or am I going to take off negative 2's in order to get to 8? I'm going to have to take the negatives off if I'm going to be left with positives. So I start with nothing. Well, not literally nothing. I'm going to start with a sea of zeros, nothing. All right, I start with nothing. And then I ask myself, am I going to put on or take off? I'm going to take off the negatives so I can be left with the positive 8. So I know my answer is negative. Furthermore, again, connecting back to multiplication, we know that a positive times a negative produce a negative. It's an inverse operation, so the signs are different in division. We should also get a negative. But again, more than that is, if I take off the negatives, I'll be left with the positives. Now, how many negative 2's do I have to take off? Well, if I take those off, then I would have positive 2, 0, 0, 0, 0, 0. I'd have only positive 2. If I take those off, I'd have 4 and then a bunch of zeros. That's only 4. If I take those off, I'd have 2, 4, 6 and a 0, so I'm not there yet. If I take those off, 2, 4, 6, 8. Got it. How many copies of negative 2 did it take? 1, 2, 3, 4. And did I put them on or take them off? I took them off. If you take off 4 copies of negative 2, you'll get to 8. So one more. Here's what you should do right now. You should click pause. No, not you. I'm talking to the people on the camera. You should click pause right now and reason your way through this one. And then when you're done, click play again and see if you agree with me. So here it goes. How many copies of 2 does it take to make negative 8? Can you imagine? Start with nothing. How many copies of 2? There's a copy of 2. 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 You can do copies of 2 for the rest of your life and you'll never get to negative 8. So that kind of leads you to the problem. The problem is I don't want to put on positive 2's to get to negative 8. I want to take off positive 2's till I get to negative 8. So I'm still going to start with nothing. I'm going to start with my sea of zeros. Start with my sea of zeros, and I'm going to take off the positives until I'm left with 8 negatives. I'm going to take them off in terms of this, how many copies of 2. So I'm going to take off 2 positives. That will leave me with 2 negatives and a whole bunch of zeros. It's not negative 8 yet. I'm going to take off 2 positives. That leaves me with 4 negatives and a bunch of zeros, still not negative 8. Take off 2 more, take off 2 more. Now when I take off all those positives, I'll be left with 8 negatives. That's what I wanted to do. How many positives did I have to take off? I had to take off 4 copies of 2 in order to get negative 8. So let me just end with this. One of the challenges with division is it's not like you look at what you have to get your answer. You have to look at what you did to get your answer. I'm going to back up here to multiplication for a minute. When we did multiplication, we kind of looked at what we had. And we said, oh, it took taking off 4 copies of negative 2 to get 8. You know, you look at what you have. But division is the inverse operation. So we're not going to look at what we had, we're going to look at what we did. So what did I do here? Did I put on or take off? I had to take off positives to get to negatives. How many positive 2s did it take? I had to take off 4 copies of 2 to get to negative 8. That's what I did here. So there you go. One last word. Let your students think and reason. Over repeated reasoning, let these rules emerge for themselves so they've made sense of them. It wasn't just something to memorize.